Hi, welcome back to Dad and Kids Coding. Today we're on day 4 of the Advent of Code for 2021. I'm Dave.
I'm Thomas.
So today's problem is we're going to play bingo. The premise is that you're playing with a giant squid who's attached to your submarine, but the bottom line is it's playing bingo. So the input looks like this. The bingo is fairly standard bingo except no diagonals. So in other words, you're going to keep taking a number until you either have a complete row or a complete column. And what we want to find out is which of the cards, multiple cards, bingo cards, is finished first. And then there's a way to score these. You basically find all the unmarked numbers, add them all up, and then multiply that number by the number that was called that made the board win, and that gives us a number. So in this case, it's 4512. So what we have to do is figure out which board will win first. We don't enumerate it, we just need to know what will be the final score if you choose that board. Okay, so let's go over to this. So I've got the data already encoded here, but I realized that before I go very far, I'm going to actually need a bingo card object, because I'm going to basically read through. These are the balls or whatever that have the cell numbers, and then these are the individual cards. So I need to be able to add values to a card to build up the card, and then I need to be able to check to see whether a number is on the card and get a return true or false, and I need to be able to ask the card what its score is. So those are the three operations I need to be able to do for the card. So I'm going to write tests to do those before I even bother with the day 4A code. So let's go over to general tests, and we'll write a so normally we would probably do this somewhat differently. We'd create a test just for the bingo class, but I'm going to do it within this existing test class. Actually, I should do it the right way. So let's go to this class, and we're going to say bingo test, bingo card test, and it's in the test for this, and I don't need this, so we will save this. Okay, so bingo card test. So let's write a test for it. So test count. So we're going to create a card. So card is going to be bingo card new. Then I'm going to add some values to this card. So card add let's add 1, 2, 3, 4, 5, and then add number 6, 7, 8, 9, 10. Then add 11, 12, 13, 14, 15. And probably I could do this faster if I just copy and paste. So this is going to be 16, 17, 18, 19, 20, and this is going to be 21, 22, 23, 24, 25. This would actually be good to do in the setup because I'm going to have multiple tests. So let's just copy this and go to the setup, super setup, and then do this. And right, so save that. So bingo card, I want it to be a new class, and I'm going to put it not in the tests, but put it over in Habit of Code 2021. Okay, and then I'm going to make this card be an instance variable. So there we go. So we initialize a card and then we add values to it. So it's a very boring card. All the numbers go up in sequence, which is fine. So the first row is 1, 2, 3, 4, 5, and the second row and so on. Okay, so we've got the setup done. Now let's go back to our test count. So we want to, first is to just see what the count is right now. So self assert card count, and its count should be the sum of all the numbers from 1 to 25. And all the numbers from 1 to 25 is, well, equals well, let's just do 1 to 25 sum. And that is 325. Who knew? Okay, not that I care, I'll just leave the code saying this. So when I create this initial card and then I ask it what its count is, the answer should be the sum of all the numbers because I haven't actually matched any numbers yet. So let's save that and let's run the test. Now it says instance of bingo card did not understand add. Okay, then we should tell it how to add. So we'll put this in bingo card, and let's call this initialization. Okay, so what do we want to do? Well, the simplest thing we want to do is we want to add cells, add all collection, and unmarked. So I'm going to keep a add all collection. So the way I'm going to do this, I'm going to keep an array that has the numbers in it because I need to know what the order of them is, and I'm also going to have a set that has all the ones that haven't been marked yet, and that's just going to make it easier to do the count afterwards. And is there anything else I need to do? I don't think so. So let's save this. And a reason I can use a set, I'm going to make these instance variables. The reason I can use a set is because any given card will have only unique values on it. Nothing will be repeated. So that's going to work. But if I run this now, it's going to fail because cells has not been initialized. So I'm going to have to leave this, and I'm actually going to create another browser. here, and I have bingo card there. So bingo card. On the instance side, I need to add a initialize method. So let's add a new method. Initialize, and we'll do super initialize because we always should. And then we will set cells to be an ordered collection, new, and we'll set unmarked to be a set new. Okay, and for now that's all we need to do. I don't know whether there's anything else we'll want to do, but that should do it for now. So now we can go back over to our test and run our test again and see how we do. So we got through the initialization. We're now trying to do count. So let's create that in bingo card, and let's call this accessing. And what do we want here? Well, the simplest thing is just to say return unmarked sum, and let's just see what the unmarked sum is, and it's 325, which is what we were hoping for, so that's good. So we'll save this and proceed, and our test passed. Okay, so that's a good start on the test. Now let's see, what should we do next? Let's call it so actually we can just continue this test. So let's remove a couple of things from the card. So let's mark something. So let's say card mark 5, and this should return false, because that doesn't complete a row or a column. So self, didn't mean to do that, self assert that marking 5 equals, actually there's a slightly, so self deny means basically assert that it's false. Okay, so that's good. And now we should get the self-assert should equal this minus 5, because 5, because I have marked one of them, and so that shouldn't be part of the unmarked. So let's see if this works. And it's not implemented, that's fine. Let's run it. And card doesn't understand how to do a mark, so let's add this to bingo card. Let's call this updating. Okay, so what should happen? So we're supposed to do two things here. One is that we need to remove this from the marked list, and the other is that we have to return true if it completes a row or not. So for now, let's just do something simple, which is if the unmarked includes an integer, if that's true, or if it's false, then that number isn't on this card, and therefore we couldn't possibly have just won. So we'll just return false. because there's nothing else to do. However, if it did include it, then we should remove it from unmarked. So unmarked, remove an integer. And what else should we do? And then we should basically go through and see whether we now have any completed rows or columns. But if we don't, then we'll just return false. So for now, that should work. And so we'll proceed. And our test ran. So taking that out left us with the sum, the original sum minus 5. Okay, so that's good. So let's now remove the other 4 cards in that row. Two, three, 4. So we remove 1, 2, 3, and 4. But 4 should return true when we remove that one, because at that point we've removed all of the first row, or we've marked all the first row. So we should, this should finally say, yep, it we finished a card. And when we're done, we should have the result should be the sum of 1, 2, 3, 4, 5. So let's just include that. So that would be minus 15. Okay, so hopefully that makes sense. So we'll run our test, and I expect it to fail here. So let's run the test, and sure enough it fails there because this returned false. Not surprising, given that that's exactly how we wrote it to do. It's not surprising that it does. Okay, so let's just put a break right here. And now let's try running it again. Okay, so we got a break just before running this. So now let's go into oops. Why did this not? Didn't stop where I expected it to stop. Okay. Well, it says it's supposed to stop before that line. Let's try one more time, because I'm surprised. So this should be about to, no, it says it's about to do the self-assert. Ah, that's not quite what I wanted. So let's just turn that assert off, a break off, and add a break here instead. Okay. Right, okay.
Did you add the stop? I didn't see an icon pop up.
Let's just, well, it stopped. It's not telling me the right place where it stopped, but that's okay. That's step into the highlighted message. It's not running the way I expect it to. Okay. Oh, I see. Do I see? say self halt. Well, I suppose I could just leave that the way it is and just add a halt here. So just for those that may not be familiar, the semicolon basically is called a cascade, and it says send the following message to the same recipient as same object that received this message. So this sends self the assert message, then it sends deny to the same place and assert to the same place, and so on and so forth. So this halt is going to self, which should halt at this point, and then we'll send this assert message next. So don't know where this temp1 came from. Let's just get rid of that. Okay, so let's run our test, and we got the halt where we expected. Worked better. Breakpoints didn't work quite the way I expected them to. Okay, so now we'll go into this Mark IV. Okay, so we'll step over this. It did include the integer, so we didn't return false. So we remove the integer, and now we want to, oh, I shouldn't have done it quite that way. Now we want to go through all the rows and columns and see whether any of them match. So let's do this in a very straightforward way. 1, 2, 5. Do index. So if self full row index, so if that returns true, then we'll return true. And otherwise, if we have a full column, for that index, then we'll return true. And if we get through all 5 rows and all 5 columns and we haven't found a matching a full row or full column, then we'll return false. But as soon as we find a full row or a full column, we'll return true. Okay, so let's save this, and unfortunately we need to go back and rerun our test because, well, I'll show you what happens because we've already removed that from the unmarked, so that's not going to work very well.
Sure it's saved?
Am I sure it's saved? I hope it's saved.
Yeah.
Yes,
okay,
it was.
There you
Okay.
go.
So we come to full row, and we haven't implemented it, so let's create it. And we could write tests for full row and full column, which might be useful, but I'm not going to. So full row. So what we want to do is we have, this is a row number, and we want to loop through this row, and so what I want is let's say row base is row row minus 1 times 5. Okay, that's the offset to the start of the row. and then we're going to say one, well, row base, oops, no, what I wanted, row base 2, row base plus 4, plus 1. Do index and if unmarked includes the element that we're looking at, then it means we haven't marked this element yet, so we don't have a full row. So if unmarked includes cells at row base, index, if that's true, then we want to return. If true, then we'll return false, because we have not found a so we found a place that's unmarked, and therefore we can't this row can't possibly match. And if we go through all those elements and we didn't find any that were unmarked, then we found a row, so we should return true. Okay, so let's just proceed. Okay, so that worked. No, it didn't work, because that's strange. I would have, what are we removing? The integer, an integer is, oh, 5. Oh.
Oh?
Not where I thought we were. Oh, we're doing this one. Oh, of course we are. Sure. Fine. So I guess we'll implement full column. Except full column is going to look just almost identical to full row. So let's go and get full row and create full column. And we're going to have a column here. And I'm actually going to do
find and replace.
Search and replace. Oh, that's pretty ugly. I want to search for row and replace with column. And it's showing me all the ones that it's matching, so we'll replace all of those. Except I wasn't in the right place. Let's find again. I wasn't in a good place for that. Okay, so okay. Now, this is not the right way to do columns. What we want to do here is we want to step through. So column base is going to be just the column minus 1. Is that right? No, the index, actually, we don't need column base. Let's use column. So column to column plus 24. No, not 24, plus, well, that'll work. I think that'll work. By 5. So we're going to go to the column, then the column plus 5, then the column plus 10, then the column plus, and on up to column plus 9, column plus 20. Right. That should give us all of the elements. And if unmarked includes cells at index, if true, return false, otherwise return true. That looks right to me. Okay, so why this isn't indented? Okay, I guess because I've told it not to indent it. Okay, so let's go back to our test and run our test. So we get to the halt. Okay, that's good. Let's just see what happens here. Aha! It returned true. Excellent. And let's just proceed. And it works. Okay.
Oh.
So that found a matching row, but we didn't actually test matching columns, so we should try the same by column. And what are we going to do differently? So let's mark 8. And then this should equal sum minus 8 because we did that. And then we're going to also mark 3 what? 13, 18, and 23. Okay, so I think that should work, except this sum is going to be wrong, but that's okay. Let's just run the test and see if we get to there. Yes, it did. So we got 260 instead of 310, so let's just change that to 260 because that sounds like the right number to me. Save. Okay, so that test passes now. So now let's go back to our admin of code test. And now we're ready to actually run day 4 because our bingo card now is basically working. We can add counts to the card or add cells to the card. We can, the counts are calculated properly, and we can find, oh, should take out the halt. We can find a match in either by row or by column. So I think we're good. Let's just run that test. Hit green. Okay. So let's go back to day 4 and run it now. So that was all preliminary. We now we need to add day 4A, put it to byte string, leave it unclassified for the moment. And now what are we going to do? Okay, so now our input looks like this string. So we first of all, we're going to get the lines of code, or lines of data. So let's say lines is self lines. Okay. Now, so the first line is the called numbers. And that's going to be lines first. Lines first split on comma. And then we want to collect all those as numbers. So that's going to be a bunch of strings, and we want to collect these using as number. Okay, so let's save call numbers as a temporary variable, and so now let's just loop over these and see what we get. And called numbers is now called numbers is a bunch of, where's called numbers? No, it's not showing us called numbers. Let's just look at it. Inspect this. Okay, so it's a bunch of values and they are small integers, so that's exactly what we want. Okay, so we have the numbers. Now we want to loop through all of the rest of the, so let's say bingo cards. Because we don't know how many bingo cards there's going to be, so we're going to make this an ordered collection. So we can add to them, and we'll have a current card which will initialize to nil, and then lines all but first do. So we'll take each line in turn. We'll build up our bingo cards, which we'll figure that out in a minute. And then once we've done that, then we'll go through all our called numbers. So called numbers do called. So given some called number, otherwise if we don't find anything, then we'll return, well, let's just halt. That would be bad. Now, let's return 0, nil. Return not found. Okay, or no winner. Okay, so so we'd get a winning number by looping through all of our cards. So bingo cards, let's save this. Bingo cards is temporary. card is temporary. Okay, so now we want to say bingo cards do card. Okay, and we want to say card mark the called number. I think I should call it called number. Okay, so if marking that is true, then we have a winner. So we should return this card count multiplied by the called number. Right? Right? That's what it's said to do. So if once we find a winning board, we get the sum of all unmarked numbers and then multiply that by the number that was just called. Okay, so that looks right. If we don't find a bingo card with that called number creating a winner, then we go to the next called number, and we keep doing this, going through all the cards and all the numbers until we find something, or otherwise we return this symbol, no winning number. Okay, so all that remains is to build up the bingo cards. So if the line is empty, then set current card to nil. So we're not currently working on a card. Otherwise, actually, is there an if empty, if not empty? If empty, if not empty, there we go. So if empty, then we'll do that we'd said. If it's not empty, then we'll do something different. So if not empty, so if it's not empty, then if we don't have a current card, current card, if that's nil, then we should create a new card. Then current card will be bingo card new. And regardless, we're now going to take the current values and we're going to say current card. Oops, so we should add that. One more thing we should do here, and add this to bingo cards. Okay. Otherwise, we are going to, or regardless, we are going to take the current card and add the current line, substrings, So we take the line, we split it into substrings, which are going to be the cell numbers, and then we convert that to an array of numbers, and then we tell the current card to add that. Who knows? It just might work. And it did. So we now got this crazy number. Save. Proceed. And we got through the, okay, so that's good. So now we need to go over here and see if we got the right number. And we did.
There we go.
Okay, that was hopefully we can reuse lots of that code.
Yeah, let's take a look at this.
Next one. Okay. On the other hand, it might be wise to try a different strategy. Let the giant squid win. Yeah, I can see that might work. You aren't sure how many bingo boards a giant squid could play at once, so rather than waste time counting its arms, the safe thing to do is figure out which board will win last and choose that one. That way, no matter which board it picks, it will win for sure. Okay.
So, appeal to ego or appeal to...
yeah, basically we're hoping to...
appeal to honor?
Okay. This sounds like it shouldn't be too much extra work. So day 4b should return this number instead. Okay. Now let's just go and look at day 4a. Oh, yeah, sorry. Let's go look at day 4a. Okay. Oh, it's still unclassified. We could change that, fix that, and instead make it be an extension of the advent of code. Okay. Now, so what we would want to do in this case is just change this code, because we want to go through all the called numbers and so pretty simple version is if we so all the first part is going to be identical in both cases. The only thing that we want to be different is actually this part. So when we find a bingo card that wins, instead of so we could do the two different things. If it's day 4a, then we would do a slightly different thing than day 4b. If it's day 4a, then we would return just that card, and if it was the other one, then we would remove that card. So, I mean, I could just duplicate this code and just change this one. Maybe that's what I'll do for now. I really want to reuse this code. I don't want to just duplicate the code. Well, let's duplicate it first, and then we'll come back and. So we have to browse this first. Okay, so day 4A. Day 4B is going to be very similar, except that when we get down here, when we find a card, we don't want to do this. We want to do something different. So let's just tell this card that we're going to ignore it. Card ignore. Okay. And we'll set current card to this card. Okay, and then here, oh, but we still have to return what its final score would be. Okay. So, oh, okay. So when we're gonna change it. So when the card returns true, it's going to remember what its called number was. So then it can calculate its score entirely by itself. So we'll add a, okay. So card ignore, current card is this, and return current card score. Okay, so the only thing that's remaining is that if the card is ignored, we want to skip it. Card to be ignored if true, if false. Okay, so a couple things we need to do yet, but so we're going to go through all the called numbers, going to go through each of the bingo cards. If we find, if the card is already marked as to be ignored, then we'll skip it, but if it's not, then we will try and mark it with this number. If it's true, then this card just won. So we'll tell it to ignore that card, but we'll remember it. And then by the time we get through this loop as many times as necessary, current card will be the last one that we did, because that's where it gets set, and we'll ask it for its score. So we'll just, for cleanliness, we'll just here set current card. Okay, so we still have to worry about to be ignored and score. I'm going to do this right, which means I should go over to bingo card test and I should ask for its score as well. So here we should assert that card score equals 0 because we don't have a score. And down here we should assert that the card score I don't have to, yeah, I just realized I can clean it up a little bit. Okay, card score should be equals to 320 is what I think it was. Times the winning mark, which was 4, so that would be 1280. I might have it wrong. Let's see. Okay, so the only problem is we don't have a score, so let's create a score method. And we'll call this accessing. And we'll just return score. Except the score could be 0, so I have to, okay, save. Make that an instance variable. Proceed. And it shouldn't equal 0 here, it should equal nil. Because we don't have a score yet. Okay, and let's go back and rerun this test. Didn't equal 1280, oh, it equaled nil because we didn't set it up. So let's, I'm going to clean up a couple of things in the process here. So, bingo card. When we mark it and we find that it's true, then we, before we return true, we should set score to be equal to an integer times self count, and then do that. Okay, so that's fine. Now, so if I go back over here, not here, okay. So, if we do this, then we can just return the card score, not, we don't need to do this part anymore because the score has already been calculated. Save that. Let's browse and look at the D4B. And we can clean this up a little bit. Okay, so I'm not going to call it to be ignored if it's already scored. Actually, we don't have to do. Let's just say if the score is not nil, sorry, if it's nil, then we want to. So if we don't have a score for it, then this card hasn't won, and we don't have to do the card ignore. Just remember the current card. So we'll loop through all the called numbers. We'll loop through all the bingo cards. If the card we're looking at has already been scored, then we'll ignore it. Otherwise, if it hasn't been scored, then we'll mark this call number on it, and if that returns true, then this is the new winning card, so we'll remember it. And then by the time we're all done, if we have a current card is going to be equal to the last one that was a winning card, and therefore we are done, and we'll just return that score. Okay, I think that's right. Save it. And run the test. And we got the correct number for this. We got the 1924, so that's good. 17.
If I remember correctly, that number is less crazy than the previous one.
Right. Okay. So let's quit and rerun this. It's green now, and the number is 17388.
That's
Copy.
larger than our previous one. Okay.
And
We're
save
losing
that.
winning, I guess.
Submit that, and it's right. So we're done. The only thing I'm going to do is I'm just going to go back over and see whether I can refactor these two methods, because they have a lot of code in common, and it would be very nice to be able to get the commonality there and just have the little bit of code that's different. So let's just see what we can do here. So everything down to this point is identical in the two of them. Right. So all that's different here is that this one, if it's true, it returns the card score. And this one, if it's true, it just sets the current card to card. So I think we'll end the video here because it's all working, and I'll refactor this and commit the code, but it's not worth hanging around on a video for, I don't think. So with the whoops, that's not what we wanted to do. So with the completion of this, we're going to bid you adieu for tonight, and we'll see you again hopefully tomorrow. Take care.
Bye.